Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, I am going to talk about the chapter 3.8 elastic strain from the load and stress analysis chapter 3 in Shikli Mechanical Engineering Design textbook. Okay. The elastic strain, okay, is a repetition of what we have learned in the previous chapter, chapter 1, which no, is chapter 2 in on the material science, on the stress strain diagram. Okay, so now we're going to talk about elastic strain. What is elastic strain? It's the deformation of material under stress that disappears when stress is removed and described by Hooke's law. Okay, uh, meaning that whatever deformation that happen, let's say, everything that you see in your life, let's say your uh, you take a rubber band, okay, you stretch the rubber band, and then you unstretch it, and you stretch the rubber band using your both your hand, and then you release your hand, and then the rubber band will come back to its original position. It is elastic strain, okay. Deformation understand that display when stress is removed. It is required by Hooke's law. I'm sure you have learned about Hooke's law. F equals to kx, okay, where k is the constant and x is the displacement. F is the force. Okay, this is the Hooke law that you learned in your high school. In Malaysia, is in physics class in sekolah menengah. Uh, Learn about this Hooke law, and you will learn again about Hooke law in more advanced. Okay, Hooke law is stress equals to Young modulus times the strain, where E the Young modulus and is a measure of stiffness. Law equals to F equals to Kx. Okay. Practical example: a steel bar stretched under tensile force elongates and return to its original shape when the force is removed. Okay. Example using stretch bar. Maybe you cannot see the elongation with your eye, but theoretically it is elongate. Okay. When then after you release the tensile, it will return back to its original position. Okay. So normal and lateral strain. Strain occurs both along and perpendicular to the load axis on it tensile stress, leading to normal and lateral strain. Meaning that when you stretch when you stretch the load, like using the ultimate testing machine, okay, UTM machine. I'm sure UTM machine is available in all engineering school throughout the world. Okay. Every engineering school must have this UTM machine. Okay, you stretch it, and then you see the it it strain, it become to the perpendicular to the load axis. You can see the load and the lateral strain lah. Okay, lateral strain is proportional to the axial strain. For most structural means, for most structural material, it is called a Poisson ratio. Poisson ratio around 0.3. Okay, this is there are equation for Poisson ratio. You can find it in your textbook. Okay, engineering application, lateral and normal strain are important for predicting how material deform under stress in practical engineering. Meaning that um, you can observe anything that you can stretch. You can see, let's say you stretch a rubber band. You can see the deformation happen at the middle of it, and also at the lateral and the elongation part of it. Okay, this is how we observe. Okay? Because rubber band is you can get it anywhere. Okay. Shear strain definition. Shear strain is the information of material when subject to shear stress, altering the internal angles. Hooke law for shear. Hooke law for shear is tau equals to G times gamma, where G is the shear modulus of rigidity, meaning that modulus of rigidity is the place that uh, where we want to indicate the whether the material can withstand the load or not, and then after rigidity, it will be beyond that, the material is brittle and fracture. Okay, shear strength can be visualized by cutting a rubber block which deform in the along the shear plane but return to its original shape. Okay, okay, when you this is a rubber block, meaning the rubber, whatever things that make of rubber, you cut it, and then after you cut it, it will return it to its original shape. Okay. 3D stress and strain in the X, Y, and Z direction are calculated using equation derived from stress relationship in multiple direction. Engineering application, the stress strain relationship are crucial in analyzing structures under complex loading, such as pressure vessel and bridges. Okay, we because we want to observe where the failure happen first. Okay, usually failure happen at joints. Okay, failure usually happen at joints. Okay, joining and welding. Okay, failure prevention, understanding strength and strength in 3D uh, helps prevent bacteria from failure in real world application. Okay, so that's the video right now. Inshallah, we meet in the next video. Thank you very much.